In the Gauteng Department of Education SciBOTICS competition in Category 3 for open source hardware for grade 10s, 11s and 12s, we have Mission to the Yellow Planet. There is a detailed video about Mission to the Yellow Planet that we would recommend that you watch. If you look at the rules for Mission to the Yellow Planet, what you'll notice is that we're giving you the code that's running in the demo robot for this challenge. The code in this challenge is quite advanced and uses some clever techniques to handle the 90-degree corners in this maze mat. Having 90-degree corners in the maze mat allows us to fit more maze onto the same size of competition challenge table. At the top of the code here, you'll see there are programming comments. Arduino program code is called sketches. So if we look at the top of the sketch, you'll see we've got a / and a star, and then a closing star and / at the bottom. What this means is all of this text is grayed out, and when this program compiles and uploads into the robot, this won't cause errors and interfere with the compiling process. The actual code starts on line 10. If we look at line 10, you'll see hashtag include open angle brackets servo.h, greater than and a less than sign. So this line of code creates an object that runs in the background and will continuously send signals to our servo motors on the robot. The next line of code is where you create a servo on the left and you create a servo on the right. The next thing we have here is a constant called left stop. That is actually a value that we just need to create at the top of the program that we can invoke later on when we need to stop the motors. We've got another one, constant integer right stop 1500. That creates a stop value for the left and the right motor. If your continuous rotation servos are calibrated properly, these would be the right values to put here. If for whatever reason you build a robot where it's difficult to access the calibration function on the actual servo motors, you might want to actually change these numbers here to the actual stop value. The next thing you want to do is define your sensors. The demonstration robot for this challenge has 6 sensors. So we have the left far sensor, the left near sensor, the left center sensor, the right center sensor, the right near sensor, and the right far sensor. Notice here we're spelling center the way American English spells center. The next few lines of code, we're defining our analog readings. If you don't know what analog and digital is with regards Arduino, you might want to just jump onto the internet very briefly and just go to Google and notice again we're following the American spelling on analog, and obviously you're going to see a bit of a AI thing appearing up here, but probably easiest just to jump into the Arduino's own website. So they've got an extensive website, Arduino, docs.arduino. So the analog read function, here's a description of how it all works. There's a 10-bit analog to digital converter on the Arduino Uno. What that does is it will render a value of a voltage between 0 and 5 volt DC into integer numbers are values between 0 and 1023 because there are 1024 steps. You can also go to YouTube and watch some videos about Arduino. Here's a tutorial about analog inputs, the way they work. So we have a read far left, which is an analog reading of the far left sensor, where we define that as analog input 0. Remember, computer systems number from 0. So we have 6 sensors on our robot. So read far left, read near left, read center left, read center right, read near right, read far right. The next thing we want to do is we want to define our leap time. What that is it's an amount of time that the robot will drive on when it reaches a corner. And that becomes important, and we'll explain it as we talk through the code. The next thing is we define your LED on 13. That's the inbuilt LED that you find on all Arduinos. And then the next thing is we've got another constant over here, which is our threshold value. Now, the threshold value is used in the program code to determine whether the sensor, the array of sensors, or a sensor within the array is over a light or a dark section of the maze. So if you look at the maze mat, you'll see that there's a black line surrounded by white. So you can create your own practice mat, or you can purchase the official SciBOTICS practice mat from SciBOTICS Discovery Center. But if you just want to figure all of this stuff out and you don't necessarily want to buy the practice mat, you can just take black electrical insulation tape against a white surface, and that way you can create your own practice arena or maze to work on. Now, this value of 44, you can have a whole range of values depending on the sensor system on your robot, how you've rigged things up, and how much light your sensor system throws onto the table itself. So let's just jump out of this programming code and have a quick look at the robot on top of the line. What you'll notice is that the line sensor, which we're looking at here, has a row of LEDs which are simply there to create illumination of the table surface at a certain level. We could use ambient light, but ambient light is going to fluctuate wildly according to where you set up your maze, and maybe you've got a window and the sun comes through late in the afternoon. So you'll notice we've put a light baffle, in other words a barrier, around our line following sensor to block most of the ambient light, and then we're just relying on the light from the LEDs that's actually mounted onto the sensor itself. The sensor is basically an array or a row of phototransistors that will look down at the line on the table to see, am I over the line? In other words, those phototransistors are looking down at the table, and the table will either be reflecting a lot of light when the table is white, or very little light if there's a black line and the sensor is over the black line. Now, what we do need to do as well is we need to create variables. And these are our variables here. There's a variable for each of the sensors where it's going to store a value that's being returned. Now, what we're seeing here is our first function called void setup. Now, a function in Arduino, if we just open a new instance of Arduino here, you will notice that, and I like to just have a, so I'm just getting rid of the comments here, and let me get rid of that comment there. So now what you'll see is this is what's called a bare minimum of code for any Arduino program. You've got two functions. So a function follows this format. So we've got a loop over here, and we've got a setup function over there. Now you can have many loops, you can have loops even within loops, but you can't have two functions with the same name. So you cannot have another function called void loop, and you cannot have another function called void setup. But these two functions have to be in any Arduino program. So for example, you might want to have a program that runs through a certain amount of lines of code, but it doesn't ever loop. You still have to have the loop there, and the loop will loop. So if you put a bit of code over there, and a bit of code over here, and a bit of code over there, and a bit of code over here, and a bit of code here. And let's say that these X's were instructions. It'll execute that instruction, then it'll execute this instruction, then that instruction, then this instruction, then this instruction, and then it'll go back to execute that one, and it'll do it all over again in a loop forever. But if you don't have anything that's going to repeat, you can have no code in the loop, but you still have to have that void loop function there. That's important, so as not to get error codes. So here is our void setup, our setup function, which basically starts over there and it ends over here. What's interesting with Arduino is if I click here, you'll notice how it highlights over there. And if I click on this closing curly bracket, it highlights that one. So there has to be a pair. Now you can have many more opening and closing curly brackets within this pair, but you have to have a closing bracket for every opening curly bracket and a closing curly bracket for every opening curly bracket. Now in this void setup function, you'll see we've got servo left attach on 11 and servo right attach on 10. Notice these are semicolons. If you put colons there, you're going to get error codes. But notice how we don't have the semicolons over there on the name of the function. But inside of the curly brackets, there's your opener, there's your closer. So anything between these two brackets must have the semicolons. Over here in the setup function, we have to tell the program where to attach servo left. In other words, which digital pin are the servo motors attached to. And on this Primo robot, they attach to 10, 11, 12 and 13, but we're only attaching a left and right motor to 10 and 11. The next line of code over here, we tell left fast sensor that it's an input in the pin mode as an input. Same over here, it's an input, an input, an input, an input, and an input. Then for our LED, that's the built-in LED on 13, which is just a signaling LED to signify that the program is starting up. Our pin mode there is as an output. Then we want to switch that LED off and on just for a second once. So we say digital right LED high. Now in the Arduino programming code, high means on. So when we say digital right LED to high, that means switch on the LED. Now we've got this command here, delay in brackets 1000. Now the 1000 is milliseconds, so delay 1000 means delay for 1 second. Effectively what that delay means is don't execute the next line of code until this delay is completed. So that will cause this code to continue to be true. Okay, so we've got digital right LED high followed by delay 1000 milliseconds. What that means is switch the LED on and keep it on for 1 second before executing the next line of code, which is digital right LED low, which means switch off the LED. And then we say keep the LED off for a second before continuing to do the next thing. Now obviously this void setup function runs through once, and then over here we enter the loop function. So what you'll see is behind the name of this function we've got // which turns all of these comments here gray, so they won't interfere with the compile functions when this code is being compiled into code to be uploaded to the robot. Basically, this is telling you that this is the main program loop, it's a function, and you can only have one function with this particular name. Here is our opening bracket. Now if we scroll down a bit, you'll see if we click outside there. Now when we click here, so that's the opening curly bracket, this is the closing curly bracket. This line of code here causes the program to jump out of this loop to a function called read sensors, and then it'll come back to this point over here and execute this code. So let's jump out of this loop and go where the program goes to have a look at this read sensors function. The next function after the loop function is actually the read sensors function, and look at this. It says void read sensors, then open curly bracket, close curly bracket, and what is in between the opening and closing curly brackets is left far equals read far left. We already saw up at the top how we defined that. So if we look at this function, we've got left far is made the same as read far left, left near is the same as read near left, left center is made the same as read center left, and right center is the same as read center right, right near is the same as read near right, right far is made the same as read far right. If you don't know much about Arduino, I would urge you to download this document. It's absolutely magnificent and wonderful thing to have. So download this document, beautifully illustrated. You could print it, but try not to print things if you don't have to. Okay, now this is a slightly different one. This one is 112 pages long. This book is also magnificent, beautifully illustrated with photographs, where the other one was illustrated with line drawings. I would recommend you download this PDF, work through the exercises. It's beautiful. It's grouped into sections, and section by section it takes you through what you can do with Arduinos in different projects using all the different parts that you get in a starter kit. Magnificently illustrated. So let's get back to our code. So we jumped out of the main loop, we went to this function which was to read the sensors. So let's go back to our loop. Here is our loop, which basically that's our loop. So we did a sensor reading over there, and now we're going to do some logic. So we're saying if the left far sensor is greater than the threshold value and the right far sensor is greater than the threshold, and then we've got a set of brackets, and this symbol here is an OR. So that and is an and there's an and this is an OR. So what we're saying is that this condition needs to be true, and this condition needs to be true, and this condition or that condition needs to be true. And if all of that is true, then we go to a function called drive straight or straight. Okay. Now we'll go and have a look at these functions in a moment, but let's look at the whole loop first before we jump out of the loop and go and look at this function called straight, and this function called done, and then this function called pivot left or right. So this is our first set of conditions. This is our second set of conditions. And then there's an else. So we're going to say if this is true, if that's true, go straight. If this is true, then go to done. But if neither this or this is true, then we perform the else, which is to pivot left or right. So let's go have a look at drive straight. Okay, so let's have a look at this. It starts here and it ends there. So effectively it's this. Now this piece of code here is actually line following code, because basically we're saying if read center left returns a value greater than the threshold, then we want to nudge it right. So nudging the robot, so if the robot has moved to the left, we want to nudge the robot right. Notice here there's a return. That means go back to where you exited the loop to come here in the first place. And there's a delay value here that's been commented out. So you can, without deleting code, you can bring code in and out of a program to see what effect it has on the behavior of the robot. So basically we've got if center left is greater than the threshold, nudge right, and over here we've got read center right greater than threshold, nudge left. In this instance, the robot has drifted to the right, which means it needs to be nudged left to get back over the line. So either this condition is going to be true, or we just drive straight. This is our drive straight function, where the robot drives straight, but it nudges right, nudges left to follow the line. See here, this comment is called motor control functions, which are listed underneath this. Now you'll notice here was a function call over here, which takes the program here. And this is actual motor code. This is motor control code. Now, I usually put the little opening curly bracket on the same line as the closer, because these days Python has become quite prominent. This code looks more like C++, although it's called an Arduino sketch. By placing our curly brackets in columns and lining things up, that's good habit to get into, because you might want to start learning Python at some stage, and Python, rather than relying on brackets and semicolons, Python uses alignment into columns. So if we look at this code here, void drive straight, you'll see there's a call to server left and a call to server right, with an instruction to write microseconds, and the values given is 2000 there, and write microseconds 1000 here. Now I'm not going to go into a lengthy explanation about these servo motors that are used on the robot. Suffice it to say that there's an entire online downloadable PDF on Robot Science website. So we can go to Robot Science. Yep, you'll find there's a diary over here, but what we actually after is we just go to Robot Science. So it's https://www.robotscience.co.za, and we click on this over here is 1 Day of Robotics Motors. There is another set of notes called 1 Day of Robotics Sensors, and that we'll also need to look at. Here we introduce the motors that's on the robot, which is called a continuous rotation servo. The reason why this robot for Mission to the Yellow Planet uses continuous rotation servos is they are very easy to learn to program, and you can control them very accurately. You're also welcome to build a little robot using little DC motors. Then you're going to need an H-bridge, you're going to need to pulse those motors. You're going to need to write quite a lot of code to precisely control little DC motors as compared to the rotation servos. Also, by using the rotation servos, you don't need an H-bridge, which is an interface between the Arduino Uno and the motors. You cannot connect DC motors directly to the Uno because it just can't deliver enough current. Here's a bit of an explanation of how these continuous rotation servos work, explaining these microsecond values that you saw previously. Just a bit of an explanation of how these motors are controlled by pulses rather than voltages. Now, here we have a little bit of code which introduces us to how to move the robot around using these pulses, and recommend that you spend some time go through these notes. The business of solving this maze challenge is quite complicated. It's quite a difficult thing. It's not as easy as one might think, and you really need to understand all of this code in order to understand the code that I'm talking you through here. The other thing that I can recommend when I'm talking you through the code for the Yellow Planet Maze solution, and I talk about sensors and analog and all that sort of stuff, that's all contained and explained in these notes. So if we click here, again you'll see here's a set of notes that really explains how the sensors on the robot works, what an analog and a digital input is, and how to do basic line following, because in Mission to the Yellow Planet you're doing advanced line following using phototransistors. This is a picture of a phototransistor which looks a lot like an LED, excepting it doesn't make light, it receives light. It's like a simple eye that can see dark and light. And basically how to connect it up, interface it to the robot, how to test it. Also, what's of great importance is being able to look at the values returned from the light sensors on the line following module in the serial monitor, and that's all explained in this set of notes. Here's some code to read a phototransistor and use it to control the robot. Here we talk about the basics of following a line with a simple sensor with just 3 phototransistors on the sensor. And then this is a very simple starter line following code, which you could use if you're in grade 8-9 and you're looking at the Thunderdome challenge in SciBOTICS. You can use this code, although you will need to add some features to this code to do the competition. Over here we have a look at the line module with 6 sensors. Well, here's one with 3 sensors. But we basically have a look at how everything gets connected up, how to view the return from the line sensor in the serial monitor, and there's the code that explains how to read the values coming in from those sensors. This code here will read values off a line following module with 6 sensors on it. And then we have a little bit of a line following challenge with some rules. And now we have some code for a better version of line following, where the robot doesn't shake as much from left to right. There's a little explanation of the breadboard that you see on the robot where you can connect things up. Right, so we were having a look at the function drive straight. Before we go back to the main program, let's quickly have a look at the motor control functions. So there's drive straight, there's stop the motors, there's pivot right, there's pivot left, there's nudge left, and nudge right. Obviously nudge left, nudge right are less dramatic than pivot left and pivot right. And that's it. So there's stop, there's go, there's pivots, and there's nudges. And those are called at various places in the program. So basically we were looking at drive straight. Okay, so we were at the beginning of the loop. We looked at the read sensors function. We looked at the straight, done. Now done is where the program is finished doing everything and the robot's all over black. So this is robot has arrived all over black. So if we look at this, the left far sensor is lower than the threshold, in other words it's over dark. The left near sensor is lower than the threshold, so it's all over dark. The left center sensor is lower than the threshold, so that's over black. The right center sensor is lower than the threshold, so that's over black. The right near sensor is lower than the threshold, so that's over black. The right far sensor is lower than the threshold. So everything is over black, so the robot's arrived at its destination. So it goes to done. We'll have a look at done in a moment. So let's go find done. So here is void done, which is stop motors. And notice here we've got a while one is true, which is true. Okay, so that's the done. Now let's go back to our main loop. This is our main loop. So we've got past this and we've got past that. We're now looking at else. The else is if these two situations is not true, then it's an else. And we don't have to state what the else is. It's just everything that's not here, here, or there. That's what the else is. And the else takes us to a function called pivot left or right. So let's go look at pivot left or right. So pivot left or right is this function here, which starts there and it carries on all the way to here. You see that? So if we click there, we'll see that the other pair of that curly, there's the curly opening bracket. So let's jump into pivot left or right and see what happens next. So the first thing we see is check 1, which enables a left pivot on 90-degree turns. So what we're saying is if the left far sensor is over black, then we want to drive straight, then we want to delay for the leap time. In other words, we want to keep driving straight for the length of the delay, which is the leap time, which you'll remember was a value of 100, but that can vary between say 50 and 150. Then we want to reread the sensors and perform another check, and the next check after the leap time is to check if the left far sensor is now above the threshold and the right far sensor is above the threshold. What that means is that the robot has driven off the line, and if that's true, we want to perform a turn left. If that's not true, then we want to do an else, which is done. And done, again, is where the robot stops. Check number 2 is where If the right far is under the threshold, in other words over the black line, then we drive straight and we read the sensors again. And there is a small delay before we read the sensors again. Now what we do is we do a sub-check to see if the left far is now under the threshold, in other words over black. And then we delay for the leap time less 20, so our leap time was 100 less 20 is now 80. Then we reread the sensors. Then we do a sub-check again to see if both the right far and the left far sensors are under the threshold. That means they're both over black, and then the robot is done. If that's not true, if an else is true, then what it means is that is true, and then we turn left. This is how the robot knows whether to turn left or right on a left turn or a right turn. So the next thing we do is we have a delay of a leap time and we reread the sensors. Now what we do is we ask the sensors if left far is above the threshold, in other words over white, and the left center is above the threshold, in other words over white, and the right sensor is above threshold, in other words over right, and the right far is above threshold over white. That means that everything is over white, and then we execute a turn right. So you'll see that's how we turn left, this is how we turn right. And then we perform another read sensors, and that's the end of this function, which was called pivot left or right. So that's how the robot finds out whether it needs to pivot left or right for a left or a right turn. So let's go back up to the main loop. So here's the main loop again, and there you'll see pivot left or right. So the first thing that happens in the loop is it reads the sensors. If this is true, the robot drives straight. In driving straight, it nudges a little bit to stay on the straight line, and then it comes back here. The else if is where everything is over black, and then it executes a done and the robot stops. The else is what I call the 90-degree corner handling code, which is how the robot decides whether to pivot left or right to follow a corner because it's run off the line. So now we can have a look again. We've already looked at this, which is the sensor reading function. Then we've got our pivot left or right code, where it runs a number of checks, and it performs the leap time where it drives past the line, and then the robot starts to pivot, and then when the far sensors come back over the line, it exits this and goes back to the main routine where it can drive straight down the line. We've already looked at the void done code, and then we've got the void turn left code. So there's the void turn left code, and here is the void turn right code over there. And what you'll notice with this code is we've got a while over here. So while read center right is below threshold, or read center left is below the threshold, it must pivot left. And then we have a while center right is above threshold, pivot left. And then we've got a stop motor function. And here we've got our void turn right. So these act as limiters as to how far the robot will turn. So the robot decides, should I turn left, should I turn right? And then the turn right and the turn left will stop the robot from turning too far. So if we look at the void turn right, it says while read center right returns a result of less than the threshold, pivot right. Then while read center right is above the threshold, so while center right is above the threshold, it's over white, pivot right. And then while read center left is above the threshold, pivot right. And then stop motors, and that's the end of the turn right function. If we look at the void straight function, we'll see it says if read center left is above the threshold, in other words over white, then nudge right. There's a delay of 5 milliseconds which has been commented out. Depending on the exact build and type of servers and all the equipment on your robot, you may or may not need that code. And then there's a return. And over here it says if read center right is above the threshold, in other words over white, it must nudge left. So the nice thing about all of this is you can put all of this code in your robot, and once you've got it running, you'll be able to see the robot doing all of this stuff in real time.